I'm going to talk about IT project management methods here beyond just Agile. But I first want to remind you of the iron triangle of project management, which says, you can have a good, fast, or cheap. You get to pick any two. And I tee that up as a lead into this slide because I'm going to compare Agile with a method that comes from Constraint Management called Critical Chain. So this is going to be a very rudimentary, but I hope enlightening introduction to Critical Chain as another tool that IT developers can have in their toolkit. And what you'll see is that it has a different philosophy with respect to the iron triangle of project management. So on the left-hand side, you can see that the row labels begin with domain and end with the objective for these methods. And then the two columns represent the methods that I want to compare and contrast. The Agile method was developed for software. And the scope of work that's accomplished by an Agile method is variable depending on the nature of the requirements, how complex they are, and their priority. So a 2-week sprint on an Agile project might deliver a lot of work in sprint number 1 and less work in sprint number 2 because sprint number 2 involves something really, really complicated. It looks smaller, but it was complicated. And so sprint 1 might deliver an app or two, and the following sprint might deliver just a database. In other words, the variable scope. But the resources tend to be fixed. If it's a 3-person team for sprint 1, it tends to be that same 3-person sprint for sprint 2, 3, 4, and so forth. So the resources over time tend to be fixed in number. And whether the time between releases is fixed or variable depends on the specific Agile method. There are, I believe, 60 different variants on Agile method. And the one that I've been alluding to so far is called Scrum. Scrum is the one that has 2-week fixed intervals on releases. An alternative to that is called Kanban. And with Kanban, the time between releases is still short, but it's variable. It could be a week, it could be a week and a half, it could be 2 weeks, it could be 2.5 weeks, variable delivery time. But no matter which Agile method you use, the deliverables are small and infrequent. And oftentimes the objective is to create a minimum viable product and to do it quickly. So Agile implements an 80-20 rule, meaning 20% of the requirements for any system may account for up to 80% of the value that system delivers. And rather than produce 100% of the requirements, if you can produce the 20% that's really critical up front, you accelerate the business benefits. And if you never get to the other 80%, then you conserve on your investment in that IT solution. So the minimum viable product says do the most important stuff first, and the less important stuff you may never get around to, and that's really okay. Critical Chain, though, takes a different philosophy on that, in that Critical Chain is meant for situations where if you deliver less than 100%, you've got a problem. Think about building a bridge. If you don't deliver 100% of the requirements on a bridge, do you really want to put your family in the van and drive across that bridge if it doesn't have guardrails and lights and a second lane and good supports underneath? No, you really want to drive across that bridge when it's been fully built to satisfy all the requirements. Critical Chain was invented for a manufacturing environment, but it's been widely used elsewhere, including services and including software. There are times when software has to be complete. And so in row 2 here, the scope row, you'll see that with Critical Chain, I said the scope is fixed. It's all relative. Nothing is really 100% fixed. But compared to Agile, you can think of the scope of a Critical Chain project as being more fixed. Later on, when we do a deep dive on Critical Chain, we'll talk about ways to cope with the uncertainty and requirements in IT. But for now, Think of it like critical chain would be useful in building a data center. You really need all the elements in place when you build a data center, or it's not going to be secure and it's not going to work because it won't have power or light or environmental controls. But with a critical chain project, the resources that work on the project are not fixed. If you need designers, they come in and do the design. If you need coders, they do the coding. If you need testers, they come in and do the testing. So over time, people move on to and off of a project. And the time or the schedule for a critical chain project really depends on its scope. The deliverables tend to be larger and less frequent, but critical chain can produce a fully viable product.